As I mentioned earlier, every type in .NET falls into one of two categories. Every type is either a reference type or a value type. A variable that is typed as a value type does not hold a memory address or a pointer. It holds a value itself. For example, integers and floats are value types in .NET. If I have a variable called x1 and it's of type int, and I use it as a variable inside of a method, if I give that variable the value 100, the value 100 is literally stored inside the memory location of variable x1. There's no pointer here, the value is wholly inside that variable. I can have another variable of type int, let's call it x2, and I can assign it the value 4, and that value 4 is inside the variable. This is unlike the gradebook variables we've created, G1 and G2, because those variables hold pointers to an object. Now, why do we have these two different types? Well, value types exist because they are generally faster to allocate in memory than reference types. That's one reason for the distinction. Creating an object is more expensive than creating a value type like an integer, and some programs need lots of value types to exist, millions of numbers, for example, in a mathematically oriented program. So value types are very fast, and they are also usually small. It takes a lot less memory to store an integer than it does to store an entire gradebook. Many primitive types in .NET are value types, primitive types being those low-level primitives that we can't program without. Types like integers and floating point numbers. These are small values that store themselves directly in a variable. And one thing we'll revisit later is that value types are typically immutable, meaning you cannot change the value of a value type. That doesn't mean I cannot change the value inside of a variable. I can always walk up to an integer variable named x2 and give it a different value. I could change it from a 4 to a 3. But that value 4 and that value 3, those values I cannot change. The value 4 is always the value 4. The value 3 is always the value 3. And an obvious question at this point would be, how do you know when you're working with a value type? And how do you know when you're working with a reference type? And how do you create your own value types? We've seen how to create reference types. Anytime we create a class like the gradebook, we're creating a reference type. But what about value types? We'll answer these questions very soon, but first let's jump into Visual Studio and do some more experiments. Inside of Visual Studio, we're doing some experiments with types inside of unit tests. And so far, we've written a test that says variables hold a reference, but now we know this is only true if the variable is typed as a reference type, which is the case for gradebook. It's a reference type. So let's be a little more explicit with this test name and say that gradebook variables hold a reference. And now write a test that looks very similar, but with a value type. I'm going to create a new test by using a code snippet. We've used code snippets before. In this case, the code snippet is test_m. I just need to type those characters and press tab twice. Visual Studio will generate a test method for me, so press tab twice. And now after inserting the snippet, the name of this method is selected by the editor. I can immediately start typing to change the name. So let's name this method int variables hold a value. And I want to write a test that is very similar to our other test. I want to create one variable. Let's call it x1, and we'll give it the value 100. Create a second variable x2 and copy the value that is inside of x1 into x2. We did the same thing with the gradebook, but in the case of the gradebook, the value that is inside the variable is a pointer. So with gradebooks, we have two variables pointing to the same object. The question is with integers, if I make a change to x1 and give it the value 4, can I still assert that x1 and x2 are equal? Let's press Ctrl RA to run all the tests and find out. And the answer is no, that test failed because x1 now holds the value 4, x2 still holds the value 100 that I copied into it. So with the gradebook variables, I can point two variables to the same object and then make a change to that object through either of those variables, and the change will be visible through the other variable. But that's not the case with value types. If I copy a different value into the x2 variable, that's completely independent from the storage location of x1, so I don't see that change reflected here. I would have to assert that these two are not equal and then run the test. It should pass, which it does. Now, if you want a good exercise to test yourself and really grasp this concept of reference types versus value types, try to figure out what would happen if I add this line of code inside of gradebook variables hold a reference. I'm going to say just before assigning g1.name, g1 equals a new gradebook. What you should do is pause the video and then think about if any other changes are required inside of this test method to make the test pass. That is, do you have to change the assert from r equal to r not equal? And hopefully you have tried that. Hopefully you came up with the correct answer. The correct answer is that I would have to change the assert because I have assigned a new value into G1. I have given it a pointer to a new gradebook, a second gradebook object. I'm changing the name of that second gradebook, but G2 is still pointing to the first gradebook that I created. Therefore, that first gradebook doesn't have a name, and that assert.r equal G1.name, G2.name, that would fail. So these are the kinds of tests and experiments that you can do inside of Visual Studio with unit tests to really see if you're understanding some of the language concepts and features. And now that we've seen how these two behave, let's answer those questions of how do I know I'm working with a value type and how do I create a value type?